Hi, everybody. I'm Shant, software engineer. Databricks, I'm going to talk about why the best data warehouse is a lakehouse. See, data warehouses just can't keep up with the variety of data sources and use cases needed today. Innovation hinges on integrating machine learning, AI, with predictive insights, and business agility requires reliable, real-time data. With a data warehouse, your data is locked in and duplicated. It's not cost-effective, especially at scale. That's why we have the Lakehouse platform. So you can see here on the left, with the Lakehouse, all of your data and analytics and AI are available in one place. You get world-class performance with the economics of a data lake. And it's one source of truth for all your data. You don't need to worry about data silos anymore. And lots of customers have already started using the Lakehouse and realizing the benefits. Johnson & Johnson has seen a 50% reduction in costs for their data workloads. They've gotten 140x improvements in their data delivery times. Atlassian has seen a 60% decrease in their infrastructure costs, and they've reduced delivery times by about a third. At Shell, 250 engineers are collaborating across 70 different use cases, saving millions of dollars when it comes to their engine repair costs. See, data warehousing on Lakehouse is made possible with Databricks SQL. This is our serverless data warehousing product built on the Databricks Lakehouse platform. It lets you run all your SQL and BI workloads at scale with up to 12x better price performance. It has a unified governance model, open formats and APIs, and all your tools work with it with no lock-in. You heard earlier about all the great built-in governance features of the Lakehouse, as well as the rich ecosystem. So I'm going to focus a little bit more on how we have the best price performance and we can break down those data silos. See, Databricks SQL was built from the ground up to be lightning fast for analytics on all types of workloads and data sets. You see on the left here, we have the 100 terabyte TPC-DS price performance benchmark results. TPC-DS is an industry standard benchmark for evaluating the value of a data warehouse. We set a brand new world record last year by having up to 12x better price performance for running this large 100 terabyte workload. You can check out the results on the link below. But also, if you look on the right, we've been focusing more and more lately on not just the large multi-terabyte big queries, we've been focusing on what is it like to get amazing concurrency for small data sets. And here you can see over the last 2 years, we've seen about a 3x improvement in the number of concurrent queries that can run together on a small data set. Also, we hit that world record around November of 2021, and it's not like we've been sitting by idly doing nothing. That exact same workload, if you were to run it today, it's actually about 27% faster on serverless. So a lot of the great benefits and innovation we're putting into the Databricks SQL, most of our customers can just get them without any worries, upgrade, or maintenance hassles. And a lot of what was there in the performance was made possible using Photon. Photon is our next generation query engine. It's an MPP execution model written native code, leveraging vectorized CPU primitives. It's a fancy way of saying it's really fast. And we've already processed exabytes of data. Billions of queries have been executed. Customers have seen anywhere up to an 8x improvement in interactive workloads. They've run their ETL at 1/5 the cost and have seen, on average, a 30% savings in total cost of ownership. Also, with Databricks SQL, you get the serverless experience. And really, this gives improved agility at a much lower cost. For your users, it means instant elastic compute. They get faster query execution without having to wait. They can scale quickly. For administrators, it's zero management. It's a managed environment. You don't need to worry about capacity and pools anymore. And it's a very simple and predictable pricing model. And of course, for IT, this is all about lower TCO. You don't need to worry about having to over-provision your environments for high capacity workloads. You can reduce idle time by having the serverless system adjust to your workload and dynamically scale as needed. And really behind the scenes for a lot of that is Databricks' expertise in AI and how we integrate that into our data warehousing experience. And one of the ways we do that is with our new intelligent workload management feature. We've combined the elasticity and flexibility you get with serverless with all of our experience building large-scale AI systems. And so what we're doing is learning from the history of your workloads. And Databricks SQL can kind of use this history whenever new queries are coming in to prioritize if it should run immediately or we should scale up the system to handle it without disrupting any running queries. And if you look at the chart here on the right, this is especially important when you have a mixed workload, let's say of large queries and small queries all running together. And the thing that we've seen is with the new intelligent workload management feature, we're able to get small queries that are submitted while a bunch of other queries are running to have about a 3x reduction in latency, where we automatically figure out the right scheduling and workload policies to kind of get those results faster. And this is nice because it's all automatic behind the scenes. The system just learns from the history of the workloads, and there's nothing to tune or configure. We've also added new predictive intelligence capabilities to our IO layer. If you look at this query over here, it's a selective query, and these are very common in most workloads. Select star from events where user ID equals 1, 2, 3. And you can normally in a typical data warehouse, you'd have to sort of choose between, making your queries fast, having them easy to set up, or an affordable economical solution. But it's really kind of a difficult trade-off, right? In most data warehouses, you'd have to make a copy of the data and put it in there, or create an expensive index on top of that data, which is just like another copy of that original data. But if the system could learn which data is needed for your query and automatically anticipate whether or not certain data or rows match your selective criteria and only pull those in, wouldn't that be much better? Like, what if it could just predict exactly the data that would meet the query conditions and put it in there? And just make it fast without knobs. And so there's a sweet spot right there where this is possible. And we do this with predictive IO. Check out the breakout talk on Photon later for more details of how this works. It's a very exciting new feature that we've added. And again, with the Lakehouse and Databricks SQL, the whole platform is open to all of your data, wherever it may be. So you can go from raw to streaming analysis simply with SQL. We have the new streaming tables feature, which enables real-time data with no complicated pipelines needed to be available for instant and immediate querying. We have query federation, which really opens up access to all your data sources without making extra copies, whether you have data living in different relational databases, NoSQL systems, different application tiers. All of that can be accessed from the Lakehouse simply and easily with query federation. And it's not just about different data sources, but sometimes even the types of data. A lot of times raw data comes in semi-structured or it's JSON. And with other cloud data warehouse platforms, you have to do complicated transformations to bring these data sources in so they're easy to query, or you have to sacrifice on performance on your semi-structured data. But with Databricks SQL, you can query that raw or semi-structured JSON data immediately without having to do any kind of transformation and still get great performance. We also, of course, have advanced analytics, so you can go beyond the basics. You can remove all of the different organizational silos between different teams by having machine learning immediately available to everyone in the organization. You can supercharge a lot of your geospatial analytics using our new native H3 support. So this gives you a way to do very common geospatial analysis at amazing speeds. And whenever SQL isn't powerful enough to get what you need from your data warehouse, we have Python UDFs to give you extra flexibility to call into a whole world of Python-based libraries and functionality. And of course, all of this is an open and flexible warehouse experience. All of the APIs are open, the data is open, which means the whole ecosystem of tools that you use today are available and certified to run on Databricks SQL already. Now, let me just stop talking to you about what makes the Lakehouse the best data warehouse, but actually show you with a demo. Okay, so here we're logged into Databricks SQL, and on the left, I'm going to go over to SQL Editor. This is where you can type your SQL commands. Today, we're going to look at a table with New York City taxi cab information in it to see fare amounts and cab ride information. You can see here, I'm connected to this serverless SQL warehouse, and it stopped right now, but we're going to fire off our query and see how it automatically starts the warehouse so that we don't need to worry about paying for resources when nothing's running. It'll auto shut down when we're done. So here's some quick rows from this table. Let's do some aggregation. Let's figure out which drop off zip generated the highest fare. So you can see here, the editor has some intelligent autocomplete and helps us write our queries, fare amount, and let's make that the total, and we'll group by drop off zip, order by total, so we can look at which zip code generated the most revenue. Here it is, 1001. Now, this isn't super helpful. I don't know exactly where the zip code is. But luckily, we have another table in the system that gives us mappings of zip codes to the actual details of that region. It's the zip map table over here. And instead of the zip, we can do, oh, there it is, primary city. And we'll group by primary city as well. Cool. And run this query, which is now just doing a join to convert those zip codes into a more friendly name. We have this query over here, NYC drop off fares. We'll give it a nice name and save it over here. And so now we can see, of course, New York is the one with the largest fare. Looks like about $44,000 for this data set. And as we were editing this query and working on it, we could go to the past executions here, and the system tracks kind of our previous queries, the results of what happened over there. So if we ever make a mistake or we want to go back to previous state, that's always available, easy to use. So this was pretty cool. And down here, you can see for this query, it knows the source that generated it, where it came from, even if you're using a different tool. I can click on this query profile and get a visual explain for the database people in the room of exactly what happened, how the query was executed, and what the general plan looks like. So here you can see our two tables, and there was a join operator in the middle, and it's pretty cool. But sometimes we don't want to just simply query the table, but for something like this, it might be useful to actually create a whole new table that already has all the zip code information in there materialized, so we don't have to work with it all the time. So this type of ETL processing is pretty common to simplify transformations for your business users. So in this case, we're going to create a whole new table called full trips, and it's really just getting the join that we did and materializing it and saving it as a whole new table. And this just goes to show that you can use the Lakehouse for a lot of your AI workloads, but also your ETL, data transformation, and reporting BI types of operations and workloads. So over here, we created our table. If I go to the data tab, this is the way we can browse into everything in the catalog and the data we have saved in the system. We can see here, NYC taxi, here's this new full trips table we created. And if I click on this lineage tab, because it's a trusted end-to-end platform, you can see that this table, full trips, if I click see lineage graph, was actually derived from these 2 other tables on the system. So you get a lot of confidence that your data quality and your data provenance is really in check with the environment. That's very cool and awesome. But of course, all this functionality is available to any of your other third-party sources that you normally use for data analysis and data warehousing workloads. If I go to this serverless warehouse that we were just working on over here, I can go to the connection details. Let's say if I want to connect from a BI tool like Power BI or Tableau, I can do it. Let's just click on Tableau. And if I wanted to write some code directly or a whole new data application using Java, Node.js, there's even little samples and starter guides to help with that whole process. And now that Tableau is open, I'm going to put in my password and just connect to that exact same warehouse that we were using previously directly from my tool. So let's pick our catalog. You see that samples catalog is available here, and we'll choose the taxi schema, and let's pick the full trips table that we were just working with. And so just like that, you were able to use the tools that you know and love today to use with your SQL ecosystem directly against the Lakehouse, giving you the full power and flexibility no matter what environment you're in. Make sure to stay tuned for the follow-on talk where we do a deep dive and a demo or showing you how to do Python UDFs, query federation, and some of the more advanced features that we talked about. That's it. Thank you, everybody, for your time. It was great talking to you and telling you why the best data warehouse is a Lakehouse.